Welcome. Welcome to Container One's Serverless Anywhere. I'm Steren Giannini, a product manager on the Serverless team at Google Cloud.
Hi, I'm Gregg. I'm also a product manager on the Serverless team. The cat's out of the bag. We can say that it's about Cloud Run now, right? Okay.
We can say it now.
Hopefully you're in the right place if you came to learn about Cloud Run. This is it. But let's give you a little bit of background before we start on that. So for over 10 years, Google has been investing in the developer experience for running on the cloud. Our very first product for Google Cloud, actually before it was Google Cloud, was App Engine, which was invented before the word serverless was even a thing. It allowed developers to write code and run it at scale in the cloud without the need to worry about infrastructure. Since then, we've also released Cloud Functions, which is a functions as a service-based product. And these two together have allowed developers to understand the benefits of serverless compute, allowing them to focus on their code and not worry about the infrastructure that is necessary to run that code. Our customers, probably all of you here today, or many of you here today, have been very successful using these platforms to run your business and recognizing the value that App Engine and Cloud Functions provide their engineering teams on lowering the requirements of running production code. We've even heard people say, Google is my SRE. I don't have to worry about having that role in my company. But serverless wasn't always accessible to everybody. There were restrictions and limitations on using our serverless platforms that caused problems. And we often heard from customers things like, I have these existing binaries that I want to be able to use, or there's a particular coding language that is optimal for the task that I'm using. When is that going to be supported? Or even Java developers, maybe Python developers probably remember, maybe it wasn't even the whole language that was available in the serverless platform. It was just a subset of it. So there were challenges, and we wanted to make this more accessible to everybody, not just the people who could fit the mold that we had. But what is serverless? How do we think of it as Google? After all of the years of running App Engine and Cloud Functions, all of the feedback from customers, we've developed a model for how we think about serverless. And it divides into two pieces. One is the operational model. This is the sort of way that serverless runs. It's the idea that you don't have to worry about the infrastructure. There's no servers to provision, no operating systems to install, none of the sort of details of how things work at that level. It's also about managed security, so ensuring that Google takes care of the details on how to secure your production environment. And then a really important piece for many of you is pay as you go, or pay only for usage. The idea that you aren't paying for provisioned servers or provisioned nodes, but only the compute that you're actually using. And there's a programming model aspect to this as well. So this is the developer experience. It's moving from being a traditional model to being more service-based, being able to have managed services that you leverage to get your work done, instead of bringing out your own dependencies or even writing those things yourself. It's about being event-driven. So instead of building monolithic applications that are focused on the application, think about how the data flows through your system and how you can attach compute to the events that are generated by that. And then there's a third piece that we think it truly means to be serverless at Google, and that is about being open. It's really the ideal of what serverless should be, not so much what serverless has been in the past. So we want to make sure that the developer experience is idiomatic. It feels natural to you as a developer. You're not constrained by what the platform has to offer. And also that it should be portable. You don't want to be locked into a particular platform vendor when you're using a serverless technology. You should be able to run it wherever it makes the most sense for your business and change your mind later on if you want to. This is the true value of serverless, all of these things, so that you can just focus on writing the code that matters, the core value of your business, and not have to worry about all the other details. Separately, though, from serverless happening, there's been another trend in the industry, the rise of containers. Containers over the last 4 or 5 years have really picked up. This is a Google Trends graph showing peak interest at the top at 100. And you can see we're at the current peak interest for containers. Containers are, if you don't know what they are a way to easily move code and binaries between environments. So you can have the confidence that the way that application runs in one environment will carry over to the next place that you run it. So you can have a CI/CD system produce containers for you, validate that they work, and then literally take the same code, the same binaries, the same container package, and run it in production and get all the same experience. In fact, it's become such a great experience for developers and operators alike that it is now an industry standard with a ton of tooling and support and an entire ecosystem around how you build and use containers. And while you can containerize just about anything, and the tools make this really easy, running containers, not always so easy. There's orchestration platforms that you need to deal with. There's Kubernetes. There's all of the APIs and lifecycle management that go into that. You have to think about how to scale your application, how to get the most out of it with all of the stuff. It really means that you need an operator running there, sitting there with your code to make sure that it's running correctly in production. But Steren, what if there was a way to do all of this greatness with containers and get all of the benefits out of this without the need for an operator? What if developers could do it on their own?
I wonder, what if it could be easier? You know what? Let's switch to the demo screen. What if I could simply, from the Cloud Console, open the Cloud Run section? What if I could click a button? The deployment form opens and paste the URL of a container image that I've stored previously in my container registry. And then, without doing anything else, without provisioning any infrastructure, click Create. That's it. That's all we need to deploy a container to Cloud Run. No infrastructure to provision in advance, no cluster creation, no YAML file, and boom, we have it. Like, I literally did not had the time to finish my sentence, but Cloud Run has imported our container, made sure that it started, and gave us back a stable and secured HTTPS endpoint to invoke our container. Let's open it. It's running. That's it. It's that simple to deploy an existing container image to Cloud Run. So yes, we are introducing at Google Next 2019 Cloud Run, bringing serverless to containers. Thank you. But you might wonder, what can I do with Cloud Run? Well, overall, the use cases are very broad. Cloud Run allows you to deploy any stateless HTTP container. So that means that any HTTP request-driven workload or workload that you can invoke asynchronously will be a good fit for Cloud Run. This kind of platform allows a wide variety of use cases. Let's take a look at some of them. We can find two categories. The first one is what we call public services. So they would be, you want to host a website automatically scaled to handle the incoming traffic. Cloud Run is great for that. You want to expose an API endpoint, the same. A backend for your mobile app, Cloud Run. Or maybe a simple webhook that you use to receive a GitHub notification, or maybe a chatbot. This is also a good use case. Everything that is automatically scaled to handle the incoming traffic, that varies over time. Then there is a second category of services, those who are not exposed to the internet. And those ones are, for example, if you are breaking out the monolith of your application, you might have created many microservices. Well, what if each of those microservices could scale independently on demand to meet the load that is needed from them? So private microservices are also a good fit. Things that are not exposed to the internet, but that are part of your overall cloud architecture. And lastly, as I mentioned, you can take those private services, but instead of invoking them directly via HTTP, you can use things like PubSub or Cloud Tasks to do asynchronous task execution, where the task is executed on an on-demand Cloud Run service. So some of our alpha testers have built many such use cases, for example, doing image transformation, video processing, document processing. All of this is feasible with Cloud Run. So over this talk, we are going to go over the three main pillars of the Cloud Run product. We will see how it takes containers and how it deploys them very fast. We will explain a bit what are the benefits of containers. We will show you how this is a natively serverless product. And lastly, you will see that you can have the same Cloud Run experience wherever you want it. So let's get started. Containers to production in seconds. This is the first pillar of Cloud Run. So yes, Cloud Run runs containers. But why containers, right? Well, first off, they allow you to run any programming language. So you're not restricted anymore about the 5 or 7 languages that Google Cloud provides. No, no, no. Any language you want, you can bring in. I brought a shell script into Cloud Run, if that is even a language. But really, anything, we've got Elixir, we've got Rust. You can try it out. Along with your favorite programming language, you can also use your favorite library from this language, but also from the operating system. Because containers also capture the OS packages that you want inside your container. And more interestingly, any software, any binary can also go into your container. And so this unlocks some very interesting use cases where it's not only about source code, it's about executing software in a serverless way. Containers have a very large ecosystem around them. For example, you will find many, many official base images on Docker Hub that are officially maintained by the language maintainers. And we have to acknowledge that today, containers have become an industry standard for packaging, distributing, testing, and deploying software. They are really, in my opinion, better than a zip file. So let me welcome Thomas from Airbus, who has been part of the Cloud Run Alpha program for some months. He's going to tell you how he has been using Cloud Run.
I'm Thomas Bonfort. I'm a cloud architect and a software engineer in Airbus Defense and Space. Aside from flying airplanes, as you probably already know, we also have several constellations of optical and radar satellites that we launch, operate, and provide services around the data that's produced from these sensors. So let's talk about serverless computing. As you can see from these vintage photos, our use of IT goes quite far back. We have actually more than 30 years of experience in storing, processing, and distributing digital satellite imagery. The nature of these several year-long programs when launching a spacecraft obviously amount to quite a large amount of stable and legacy code and infrastructure. But we started our move to public cloud platforms a few years ago. In that perspective, I was very excited when Steren proposed us to be part of the alpha tester program for Cloud Run to experiment ways in which we could shift our usage of compute power for this use case. As part of our move to cloud platforms, we recently opened the One Atlas digital platform to provide pay-per-use API access to tasking satellites to acquire imagery when specific conditions are met, maybe time windows, weather conditions, or recurrence. We provide also download and viewing access to raw and processed imagery. And we also extract analytics from these raw data and provide insights such as vehicle and infrastructure detection, change monitoring, precision agriculture, or deforestation monitoring. Now, fueling this platform actually requires ingesting thousands of images every day. Each one of those images is composed of several billions of pixels and weighing in at several gigabytes of raw compressed data. Under the scenes, this leads to quite a few challenges. We want to minimize storage size, and we want to efficiently respond to on-demand access to provide services without over-provisioning compute instances. So let's explore a scenario where Cloud Run can help us with that. For this use case, we'll be transforming our raw imagery into the growing industry standard that's called the cloud-optimized GeoTIFFs, which is just a standard TIFF file, but where all the imagery metadata and pixel indexes have been stored at the beginning of the file to be compatible with object storage get range requests. So our first step is a batch process which will ingest our raw imagery and transform it into these cloud-optimized GeoTIFF files into a cloud storage bucket. Jobs like these will be continuously launched whenever a new image becomes available. So now in the second phase, in order to be able to service requests to clients who want to only access parts of these imagery, we can deploy Cloud Run services, which are just Docker images that contain any low-level code that will be able to access and transform the raw pixel data from the GeoTIFF files, and to fit the need of analytics jobs, machine learning, training, and inference jobs, or just interactive viewing. So why is Cloud Run a great fit for this use case? Being able to run custom code on the serving instances allows us to store the data only once in a pivot format, while still offering the full range of services at request time. And this lowers our recurring storage costs by avoiding duplication of data. We also take advantage of the scaling down to 0 instances to be able to deploy as many services as we need. And the scaling up of the instances also ensures us that our services are available and will absorb any usage spikes. Now, in situations where using public cloud isn't feasible, the Knative roots that Cloud Run is built upon will allow us for code reuse and shield us from lock-in. So yeah, all in all, we're excited to continue exploring use cases that can be unlocked by Cloud Run, and just can't wait for it to be available in Europe.
It's coming. Thanks, Thomas. Thanks a lot for being a part of the alpha and for the tremendous feedback you've provided. It's great to see how you are leveraging the power of containers to run your own binary in a fully auto-scaled environment that is Cloud Run. Okay, so let's go a bit about how we get to a container. Just maybe that's obvious for some of you, but let's go over this. The first thing is to actually code your service. On Cloud Run, we have a few requirements for you. Not a lot, but very important ones. So we call that the container runtime contract. Any container that meets those requirements will be able to be deployed and auto-scaled on Cloud Run. The first one is that the request and the pub/sub events and any other asynchronous task are going to be delivered to your container via the HTTP protocol on a given port. So from your side, as a developer, you have to listen for HTTP requests on that port. You know how to do that, right? The other very important point is that your container should not rely on local state. Of course, you can use persistent storage, like databases and blob storage. But inside a container, you can only rely on temporary state. The thing that you create, because of the nature of the auto-scaling of Cloud Run, will not be here necessarily the next time we invoke your container. And so to store state, of course, Google Cloud has many options: Firestore, Cloud Storage, BigQuery. So once you've built your app that meets those requirements, you can package it up into a container image. So we call that the build phase. So it's literally, we take all of those files, run a command, and end up with a container image. To do that, the obvious tool that everybody knows about is Docker, right? Docker build, Docker push. This is what will transform your local source into a container image and push it to container registry. But Google Cloud has another product for you that is Cloud Build. And Cloud Build allows you to do just that, building your container, except that this time it's doing it in the cloud. So you don't even need to have the tooling installed locally. And once again, like any serverless product, you pay per usage. So when you don't build, you don't pay, and you just pay for the time of your builds. So Cloud Build can build Docker containers, can do even more complex builds, and can also help you automatically deploy your container image to Cloud Run. And lastly, we should mention that containers are a very good fit with continuous integration and continuous delivery. For example, you will build your container once, test it locally, test it on your continuous testing system, push it to staging, making sure that everything is good on staging, and then take that exact same container and deploy it to production. The container stays the same, because that's very important. Like, the thing that you tested is actually the thing that goes into production. So containers are a very good tool for that. And as I said, Cloud Build can help you achieve the continuous integration and continuous delivery. But of course, you can use whatever tool you want to do that. And the last step is to run things. So here, we go from one container image in a Google Cloud Container Registry. And with one simple command or one click of a button, we deploy that to Cloud Run. On Cloud Run, as you've seen, you get a stable and secured HTTPS URL that you can decide or not to expose to the internet. And this happens, as you've seen, in just a few seconds. So the demo I did was really a Hello World container. I want to go over those steps with a real use case. Let's switch to the demo screen, please. Yes. OK, so what I have here is just a bit of Python code that is listening for incoming HTTP request. And then it's invoking OpenOffice. Because what our microservice is doing, it's converting Microsoft Word documents into PDFs. And to do that, we just call LibreOffice to get us a PDF. There is another very important file in my web service here. As you might know, it's named Dockerfile. If you don't know this, don't be scared. It's super simple. Let's take a look. Like literally 16 lines. The first line is me using what we call a base image. A base image will contain already all of the packages and tools to run that particular language. In our case, it's the official Python base image maintained by the Python community, or maybe even the Python maintainer. We also have a line where we install OpenOffice, because as you remember, we invoked OpenOffice, so we first have to install it from the regular Alpine package manager. And the last step is to specify our start command. That's all we have to do. Start command tells how to actually start our code. So as you remember, the next step is to build that into a container image. I could use any tool, but I'm going to use Cloud Build. Gcloud build submit. I give it a tag. And here, I directly point to a Google Container Registry. Oh, no, there is a typo. It's submit. OK, so what's happening here? Gcloud is uploading my local source and then triggering a remote build using Cloud Build. Because OpenOffice, it's quite a big software, quite old. It has, probably in Java, it has a lot of dependencies. Because of all of that, it can take maybe up to 2 or 3 minutes to build. So I will spare you this. I actually built it before the demo. So let's go to the next step. The next step is to deploy that to Cloud Run. You have seen the Cloud Console UI, where you can simply open a form and deploy. Here, I'm going to use the command line, which is gcloud beta, because we are still in beta, run, deploy. Then I pass an image. So as I told you, it's in Google Cloud Container Registry. Run-intro is our project name. And the image that I built before is PDF-service. Let's hit enter. Without more configuration, Jikla is going to ask me, where do you want to deploy? And yes, Thomas, today it's only US Central 1, but stay tuned, the other regions are coming. Then it's suggesting for me a service name. Well, sounds good. And it's asking me, do I want to allow an authenticated invocation to my service? This means, do I allow anybody to invoke that service? And for the sake of the demo, I'm going to say yes to show it to you in my browser. Right here, same as before, Cloud Run is importing our container image. It's creating a revision under the hood. Right now, it's performing a health check. So that means it's making sure that my container can start and listen on the appropriate port. You remember, they listen for HTTP request on the port, on the given port. And we are done. We get, let me zoom out a little bit. We get a stable URL under HTTPS. Let's open it. OK, so this microservice converts docs to PDFs. Let's give it a doc, upload it. So here, my doc is uploaded to my microservice. Under the hood, Cloud Run is invoking OpenOffice to convert that doc into a PDF. And we get back a PDF. So this is the PDF that I got back from Chrome, from Cloud Run viewed in Chrome. So that's it. Importantly here, I only had to pay when my service was actually processing my request. Right now, it's scaled to 0. I don't pay anything. It's only when I send a document and when I process a document that I actually am charged for the resource I'm using during that processing time. Now, we head over to Ryan, and can we switch back to the slides to tell you all about how this is serverless?
I'm back. So that was a really cool demo of how easy it is to take a container, actually even take Python code, build it into a container, and deploy it using, I don't want to call it old, I'll call it legacy, vintage software that's now running serverlessly. But what does it mean by natively serverless? How do we think about how serverless and the principles that I defined earlier apply to Cloud Run? So first of all, in the old world, if you were doing this on, say, Compute Engine or even Kubernetes Engine, you would have to provision servers. You'd have to think about how to scale your workload and how many servers you might need to be able to transform thousands of PDFs on demand. And really what that would mean is that you would have to over-provision the number of servers that you bought because you wanted to make sure that there was enough capacity to handle all of the load that was coming in. The great thing about Cloud Run is that you get to do all of that without having to worry about any of it. Google takes care of it for you. So you as a developer can just focus on the code that matters and let Google run all of the infrastructure. We give you a URL. We automatically provision TLS certificates to give you a secure endpoint. We take care of the redundancy and the automatic failover. We make sure that everything keeps working so that your application can scale with you as more and more users start using your service. And as Steren said, it's all pay for use. So what does that really look like? This is really simple, right? When you have no requests, there's no instance of your application running. The container is put to sleep. Later, when a request comes in, we'll quickly spin up that instance of the container and start serving traffic out of it. And Cloud Run supports concurrency, so we can serve multiple requests out of that same container. As more load happens, we'll create more instances of that container to handle the load appropriately to keep the latency low. And then as the requests start to trail off, we'll spin down instances of that container so you don't have to keep paying for them. Actually, you don't have to pay for them anyway. What does that look like, though, on the monetary side, Steren?
Well, because of this auto-scaling mechanism, we are able to give you a pay-per-use billing model. So that literally means that you are only paying for the resources that your service is using. In practice, that means paying for exact CPU, exact memory, and number of requests performed during the processing of those requests, down to an increment of 100 milliseconds. Once the request is out, this is 0 on your bill for you. And so, as Ryan said, Cloud Run scales up. So we wanted to show that to you over a demo. So let's switch to the demo screen. What we have here is a load testing tool that will send many requests to the container that we just deployed. So you remember our container is Our container is processing PDF. So you remember that the PDF processing time is not instant. It takes a few seconds to download the PDF and then transform it, download the doc and transform it into a PDF by invoking OpenOffice. So what you see here, I asked the load testing tool to transform 1,000 PDFs in 1 minute. And here, what you see is the scale up of Cloud Run, which OpenOffice being a quite big software, takes some time to load. So that's why we see some higher latency. And then, so here we have processed maybe 500 documents in roughly 30 seconds. And overall, the latency, OpenOffice takes 10 seconds to start and process our PDFs. Going forward, it will this time will go down because once a document has been processed, Cloud Run is able to reuse the warm instance in order to process the next one. So of course, the latency of the startup will take a bit more time, but once Cloud Run has many warm instances for you, over time things will settle down. And here we processed 900 Word documents that were stored in Google Cloud Storage in a minute. So if you're interested in scaling performances, Jason in his breakout session went up to 10,000 instances with his Cloud Run service. However, here I just showed you sending some load on a real use case, which is processing documents, which takes many seconds. So that's why we haven't seen that much high scaling. But overall, 1,000 PDFs in 1 minute is quite good.
It's pretty cool that you took a 2 GB container with OpenOffice and ran it serverlessly.
Yeah, the container is literally 2 gigs, and we looked at it.
OK, so if we could switch back to the slides. So that was a good demo about how Cloud Run can autoscale. The third pillar of Cloud Run is one experience where you want it, which is all about portability and openness, that last pillar of the developer experience that I introduced at the beginning. And portability probably means different things to different people in the room. So it might mean being able to take your workload that you started on-prem and being able to move it to the cloud. Or it could be about portability of your own understandings and experiences as a developer. The great thing about Cloud Run is that we wanted to make sure that we satisfied both of those constraints. We wanted to make sure that if a developer had to learn something new to use this platform, that it could be reused on every project they would work on in the future, that those skills could transfer again and again. And Cloud Run has a great promise. But I'm going to take a side note here, because I've talked about containers, and I've talked about portability. And if you know Google at all, you're probably thinking, like, hey, what about Kubernetes? What about Kubernetes engine? That's what I think of when I think of containers and portability. And you'd be right. Kubernetes is a very portable platform that supports running containers really well today. However, Kubernetes is really fantastic for the operator, but doesn't do a whole lot for the developer. You still have to think about how to scale your application, how to do the network programming, how to manage all of the details of how your container will run on Kubernetes. And as Kelsey said, Kubernetes is a great starting place. It's a great platform for building other platforms. It's not the end game. And this is where Cloud Run comes in. Cloud Run and its component, or its sister component, Cloud Run on GKE, provide the serverless experience anywhere that you need it to be. So like the Cloud Run managed service that Steren was showing you, Cloud Run on GKE gives you many of those same benefits. The same flexibility and the control to run a container, any container, on your Kubernetes cluster. You get the same auto-scaling benefits, including scaling to 0. You can even take advantage of GKE-specific features. So you can use custom machine types. You can ask for incredibly high amounts of memory. You can use hardware accelerators like GPUs and TPUs. And you can have access to the VPC networking. All of this lets you use the benefits of Cloud Run on your existing Kubernetes investment. So you can be fully serverless, and run on the regular the regular fully managed Cloud Run, or you can have that same developer experience, the same tooling, the same API, and run it inside your Kubernetes Engine cluster with Cloud Run on GKE. And now to tell you about why this truly matters to our customers, I'd like to invite Guillaume from Birds up to the stage to tell you about his use case.
Hello, everybody. I'm Guillaume Blaquiere. I'm data delivery team leader at Birds. Birds is a branch company of Veolia. Veolia is a major French company with 170,000 employees over 50 countries. The core businesses of Veolia are water, waste, and energy. Birds, it's the branch company of Veolia specialized in IoT, which design the devices, have tools to deploy and configure the devices on field. We process the data, we store them, and we deliver services to our customer. And all of this work on a low-power network with our legacy protocol, but with also the new ones like Sigfox, LoRaWAN, and NB-IoT. The main business of Birds are smart water meter, which represents 90% of our assets on fields, with devices designed to live up to 15 years on lithium battery. These devices have to be deployed on field by a plumber with special tooling to plug and to configure the devices. This step takes time and thus takes money, because a small city is more than 10,000 water meter to deploy. That's why our customers don't want to deploy devices on each contract and want to reuse Birds devices all their life long, even if it's not a Birds or Veolia as prime contractor. And thus, they also want to decode the Birds messages on their own at the end of the contract with Birds or Veolia. That's why we have designed this solution where IoT operator send us messages through webhook. We push them to PubSub to absorb some peak of charge. PubSub push the messages to the decoder to deduplicate, decode, and valorize the data and store them into BigQuery. Periodically, a scheduler triggers a container to extract the data from BigQuery and to load them to a low latency database for serving our websites. The customer who want to host and to process the decoding by themselves have the capability to deploy on their cluster with Knative this part, and it could be on GCP or on other cloud provider or even on-premise. With GCP, we have two solutions to deploy our container. And for the message acquisition, it's quite simple because it's independent, simple and light, and we have to absorb some peak of charge. That's why we have choose to deploy it on the fully managed solution. On the other hand, the message processing have to access to on-prem data through a VPN and just through a VPC. And custom VPC are not yet implemented in a fully managed solution, and we have choose to deploy it on GKE. Moreover, this decoding part have to access to stateful resources like Redis pod or persistent volume. That's why GKE is the best place. The third part, the data preparation, is quite difficult to choose. Indeed, there is inference call and can be quick if there is a few data and few customer, but can be too long for the fully managed solution if there is many data or customer. Today, it's not a problem because with the same code, the same container, the same UI or the same command line, if you want, it's really easy to move from one solution to another one. You only have to specify or not the cluster, and the solution is deployed on one solution or the another one. It's very easy and really, really good. Thanks, Steren and Ryan, for that.
Thank you. Thank you for that great use of Cloud Run and Cloud Run on GKE, and really showing how the portability of that experience is important for you. I'm going to do a quick demo of how this works, just to prove that everything that we said is true. So if we could switch back to the demo machine. We're back here in Cloud Console in Steren's demo project, and I'm going to just create that same service that we watched Steren deploy before. So I'll do gcr.io, run intro PDF service. And this time, instead of deploying it into the fully managed service, I'm going to choose from the location dropdown this highly available Kubernetes cluster that I've created before. And I'll pick the default namespace, and I'll just click create. And so just like before with Cloud Run fully managed, now Cloud Run on GKE is deploying the service, bringing in the container, creating a URL for me, and making everything work. And so now this is actually running on my Kubernetes instance. So if I click on this URL, you'll see here's the same application. It says running on Cloud Run on GKE, just in case you didn't believe me. And then we can switch back and actually look at the Kubernetes UI. And I'll show you again. If we go to workloads, for example, you can see down here the PDF service has been deployed onto this Kubernetes cluster. And if I switch over to services, and for those of you who are unfamiliar, in Kubernetes land, services are about networking, not about services. You'll see the PDF service here with both an external name and a cluster IP address. So this service that I created, or that Steren created earlier, is now running inside my Kubernetes cluster using the same API, the same UI, the same experience. I didn't have to change anything, but I could easily deploy it into Kubernetes or into managed serverless. If we could switch back to the slides. Thanks. So we have shared tooling. We also have a CLI. Instead of specifying the region that you want to deploy into, you specify the cluster name that you want to deploy. It's very simple. But how do we do all of this? We could have done it in a number of different ways, but we did this based on the Knative project, which is an open source project for serverless building blocks on Kubernetes that we launched last year at Next, about 8 months ago. That provides the common API, the common runtime contract, and a reference implementation for how to do everything that we've shown here today. It implements learnings from Google and has more than 50 different companies who have contributed into the project. So it's really taking this standard approach to how to run serverless workloads on top of Kubernetes. And it provides this portable experience between both of the managed services that we offer on GCP, as well as being able to take it anywhere that Kubernetes runs. You can deploy Knative onto that Kubernetes cluster and have the same tooling, the same API, and everything working there. And in fact, at the developer keynote tomorrow night, Steren and I will show you how we can even deploy that onto an IBM cluster running managed Knative that really emphasizes that portability. And you can learn more by going to knative.dev.